Okay, now we're going to look at some specific examples on what can happen with a continuous function when you got certain things happening, like you have some open circles or you have some arrows. Okay, so the first thing that we're going to look at is you have something that's continuous. It's not just dots, it's actually connected. And one of the endpoints of the graph has an open circle. So I'm just going to pick one of the endpoints, and instead of actually having a point there, I'm going to draw an open circle. So we're going to pretend there's an open circle there. Okay? So remember, for the domain of a continuous function, we have to see what's my minimum and a maximum x value. Okay, so it's the same function as earlier. So going along the x-axis, this graph is starting at -6. So that's going to be my lowest value on the x-axis. So it's going from -6, and then still following along the x-axis, this graph is ending at 0. So there's the two ends of my graph, my minimum and my maximum. My maximum is at 0. So anytime you're looking at domain, you want to follow down to the x-axis so that you can find the minimum and the maximum value. Okay, so my x values are going from -6 and ending at 0. So when you have an open circle in the graph, it's kind of like having an open circle on a number line. So we've done these where we graph on a number line, and we have a number here with an open circle. And what that means is that 5 is not actually a solution. So we either usually use the less than or the greater twos. We don't include the or equal to symbols at the bottom because this number is not actually equal to. So same thing here. At -6, I have an open circle. So I'm just going to draw a less than symbol. I'm not going to include the equal to. Now, when x is 0, if I follow up to the line, I have a closed circle, so that one does get the less than or equal to. So open circle is just less than, closed circle is less than or equal to, the same way as when we talked about inequalities. So now we're going to look at the range. So to find the minimum range value, I need to start at the bottom. So I'm going along the y-axis now until I hit the bottom of the graph, and that's going to be right there at -4. So -4 is my minimum y value. And I see at -4 I have an open circle, okay, which means I need a less than symbol. And then if I keep following the line and going along the the y-axis, the maximum value is going to be at 8. Okay. And there's a closed circle at 8, so I need less than or equal to 8. So you need to know that when you have an open circle, one of these is going to be a less than symbol. If you have two open circles at your two min and max points, at your two endpoints, then everything should be a less than. So if you have one open circle, one of the inequalities should be a less than. If you have two open circles, they both need to be less thans. Okay? So that's the first thing that can happen on a graph, is you have some open circles. Another thing that can happen is that you have the line or the function, and you have arrows going in one direction. Okay? So I'm going to go ahead and make this have an arrow in one direction, and I'll make it go up, I guess. So I'm going to continue this, and then I put an arrow at the end of the graph. Okay? So, looking at the domain, my x values, still need to figure out what's my minimum, what's my maximum. So when I take my ruler and I hit that graph at that minimum value is still -6. And we'll just leave the open circle there, so x is everything greater than -6, and if I'm following along the x-axis and trying to block off so this is where the line ends on the graph. And it looks like it has an x value of about 1.5, but really that maximum value is hitting an arrow, and an arrow on a graph means this is going to keep going forever. It's basically going to just keep going until infinity. So my maximum is going to be infinity. So x is everything starting at -6 and going to infinity. Now, if we want to rewrite this so that we don't include the infinity, if we want to just take it off, this is really saying that -6 is less than x, or if you read it backwards, x is everything that is greater than -6. So I'm going to rewrite this backwards. So x is everything that is greater than -6. Okay, now I'm going to do the same thing with the range. So I'm going to follow the y-axis, and at the bottom, I finally touch that graph right here at -4, so -4 is my minimum value. And we have an open circle right there, so y is everything greater than -4. And then if I follow along the y-axis to the top, I hit that arrow again at the top. So again, the arrow means that it's going to keep going all the way to infinity. So I'm going to rewrite it backwards again so that I take off the infinity. So I have y is everything from -4 to infinity, but if I take that off, it reads -4 is less than y, or if I read it backwards, y is greater than -4, so I'm going to rewrite it that way. Y is greater than -4. Okay, so this is what happens when you have arrows going in one direction. And it's not necessarily just one arrow, it's just that they're going in one direction. So you could have a graph that looks like this U-shaped one right here, and it has two arrows on it, but they're still only just going in one direction. You don't have one going up and one going down. Hee, I just did that. And they're both going up, so that's still, you're just going to have an inequality that looks like this. X is greater than or x is less than a number for the domain. And then the same thing for y for the range. Okay. And now one more option you could have is when you have two arrows and they're going in two different directions. Okay, so I'm going to go through this one a little bit more quickly because we've done the whole min-max thing a lot now. So if I look at my domain, my minimum is hitting an arrow, and my maximum is hitting an arrow. So this means my x values are basically going from infinity to infinity, one towards the negatives, the one that's going down, and then the other one towards the positives going up. So x is basically everything. It's going forever into the negatives, and it's going forever into the positives. So when x is everything, when we have infinite solutions, we put x's all real numbers. Okay? And then the same thing for the range. So I see the bottom of the graph